So in this case, we have got another typical exam question that we are going to use as we are preparing for the exams which are ahead of time. That was from the KZN, which is paper one, again, the 2024 exam. So we want to relate to what we had in the previous exam papers. We know that the more question papers that we work with, the more that we can understand how these questions are given. So that was a 2-hour question paper out of 100. So let's see. Make sure that you go through your instructions and information as we are given to answer all the questions, and where necessary, our answers, they're supposed to be given to 2 decimal places unless stated otherwise. So we had the first part of our question one, where we are given 1.1, the value of the square root of 70 lies between two integers. It lies between two integers, meaning to say there are two integers that we are going to have, and the square root of 70 is in between. It lies between two integers. So determine these two integers without finding the exact value of what? The square root of 70. To say, do not find it square root of 70. Guys, even if you are to find it, who is going to know that you have used your calculator to determine the square root of 70 to see that it's 8,36 and that? No one. You can do that. Know it. It's best that you as an individual, you know it. They'll be just tricking you there, guys. 8,36 and so on. Then you just know, all right, if it is 8,36, you focus with what? The whole number there, which is the 8. It will be like we are dealing with the least or the smallest value, which is an integer, a whole number. The next one being what? Being 9. So you know that, all right, if it is 8 and 9, what is 8 squared? 8 squared is what? 64. What is 9 squared? It is 81. So if you know these guys, we just know, all right, this is square root of 81. This is square root of what? Of 64. Yes, they said without using a calculator. But you can just use that. No one is going to know that you have used a calculator there. So, all right, in the exact manner, let's say we are to simplify this. All right, what can we do? We can just consider to say, as we are given a square root, you focus with what you're given here, the square root. It means the numbers, for them to be integers here, because this one is supposed to be what? An integer. This one is supposed to be an integer. For these two to be integers, it means we are talking about square root of what? Perfect squares. It's supposed to be a perfect square that you're given there under the square root. So you just ask yourself to say, which are the perfect squares that surround the square root of 7, that surround the 70, because 70 is the one that is under the square root. So now you focus with 70 as a number, as it is to say 70 is not a perfect square, but it is surrounded by which perfect squares? Which perfect square do we have before 70? Which perfect square do we have just after 70? We are dealing with perfect squares. So 70, as we are going down, we are going to see that the perfect square that we are going to first have will be what? Will be 64. There will be nothing there. From 70, 69, going down, you'll be seeing that up to 64, which is a perfect square from what? 80 squared. Then going up 71, 72, and so on. The least that you are going to be having will be 81 as a perfect square. So those are the ones that you are going to need. So it is square root of what? 64, which surrounds 70, and the square root of what? Of 81. So you work with the perfect squares. That is how you can answer this question without just looking into the calculator. But even if you just use the calculator, just like I illustrated before, guys, no one is going to know that you have used a calculator there. All right. So that was it for 2 marks. All right. Then consider 1.2. It was to convert the following recurring decimal fraction. All right. So it was not properly written here. It's supposed to be like this. It was 2 of them on 2 on 3 again, to a common fraction in its simplest form. All right, so that's our 1.2. So we're going to let our x in that case to be equal to what? 0, 0.2, 3 as given. So we need this to be written as a common fraction a over b to show that it is a rational number. So they can ask the same question to say, show that 0.23, this one that we are given, can be written as a common fraction, or they can say it is what? A rational number. Can we show that it is a rational number? So remember that this is simply a repetition that we are given there. X is equal to 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, and so on. So that is the exact concept, 0, 0.23, and so on. So if you were to multiply this, as we can say this is our equation 1. If we were to multiply our equation 1 by 10, we were going to obtain 10x, which is equal to, remember, by multiplying by 10, we're just going to move 1 comma to the other side. So this is what was going to happen. You're going to move the comma here. So it was going to be 2, comma 3, 2, 3, 2, 3, and so on, which is actually different from what we are seeing, because we are starting with a 3, not starting with what? We are not starting with a 2 there. It's supposed to be 2, 3, 2, 3. Take note. So meaning to say our equation 2 is not useful. Our equation 2, it is not useful. But if we are to multiply again by 10, this equation 2, all right, we take our equation 2, we multiply it by 10. So it means now it is 10 times 10, which is what? 100x. Multiplying this by 10, we're just going to move comma to the right. So it's going to be 23, comma. Now it is here, so it's going to be 2, 3. So remember the concept. 2, 3, after that, another 2, 3, and so on and so on. So it's a repetition that we are going to be having of this 2, 3, 2, 3, 2, 3, and so on and so on. So we can see that the equation 3 is the same, the decimal places that we are seeing there. The decimal places, the digits that we see after the comma, in this case, are exactly the same. So you focus with that part, equation 1 to equation 3. So you're going to subtract. So in that case, guys, it is up to you the way that you're going to subtract. Are you going to say equation 3 minus equation 1? Are you going to say equation 1 minus equation 3? That one, it is in your hands. So I'm just going to take direct as it is. Equation 1 minus equation 3. All right, so let's subtract and see. If we subtract, let's just remove our equation 2 because it's not useful, this one. All right, so let's subtract. That's 1x. So that is 1 there. 1x minus 100. So if we subtract 1 minus 100, it's going to be 99, negative 99x. All right, the same thing. These at the right side, we're going to subtract. So as we can see, these are exactly the same. 2, 3, the 2, 3 there. So do not focus on that one. Just subtract the whole numbers that we see. So it's 0 minus 23. So that is going to be what? Negative 23. All right. So that is what we have there. Divide by negative 99 to obtain the value of x. So as we can see, our x can be written as a fraction, which is what? 23 over 99. So that was the question to say we must show that the given recurring decimal can be written as a common fraction. It can be written in the form of a over b, which is, it is what? A rational number. So it follows that all recurring decimals are what? Are rational numbers in actual sense. All right. So that was the condition of our question. Let's consider the other part. All right. So we are given that was 1.3. Simplify the following completely. All right. So 1.3, I'm just going to move this one aside so that we can properly see this one. So starting with 1.31, we have got two brackets there. All right. So that's 1.31. We are given two brackets. Just going to start with the linear, this one with the linear terms, 3x plus y. All right, the order does not matter, guys. All right, so here I'm going to start with 3x plus y like that, which is multiplying this bracket 9x squared minus 3xy plus y squared. All right, so this is what we have. So in our expansion, we do understand that the first bracket is going to multiply everything in the second bracket. So the terms that we are given here, which is the 3x and the y that we are given here, which is actually the plus y as it is going to affect everything in the second bracket. All right, so let's start with our 3x. So that's 3x times 9, which is going to give us what? 27 there. So we're going to have 27x to the exponent of 3. Take note, x times x squared. We are multiplying. So we add the exponents there. So it's going to be what? X to the exponent of 1 plus 2, which is what? X to the exponent of 3. Okay, so the same, we multiply 3x to negative 3xy. So that's 3 and negative 3, which is negative 9. X and x is going to give us what? X squared. We just add exponents there. So it's just like x to the exponent of 1 and x to the exponent of 1. So you add those two. That was going to be x squared. All right. Then we also have the 3x, which is going to multiply the last term, which is y squared. So it was going to be 3xy squared like that. So you must at least follow or consider the arrangement that you have, like in terms of the given terms that we have. We've got x and y there. So as we can see, we started with x followed by y, started with x followed by what? By y. So do the same thing when you are multiplying this y to the other bracket. So you must consider that order. So y times 9x squared. So that is going to be positive 9x squared y like that. So we're going to start with x followed by what? By y. Okay, we do the same thing. That's y times minus 3x. In that case, we are going to obtain a positive to a negative. That's a negative 3x. Y times y there is going to give us what? Y squared. So the order x followed by what? By y like that. Then the last term, that's the y times the y squared at the end, which is going to give us what? Y to the exponent of 3. So this is what we have. This is what we have. From there, we simply need to collect the like terms. So do we have anything related to x to the exponent of 3 along this equation, along this expression? We do not have. So this one is just going to remain as it is. That's 27 x to the exponent of 3. All right, we check where we have got x squared y, x squared y. Those are like terms. Same exponent, same variable as given. All right. So we need where we have got x squared y like this. X squared y. So if we are to simplify that part, that is what? Negative 9 plus 9. So as you can see, this was going to what? This was going to cancel. Minus 9 plus 9, that's what? That's a 0 there. All right. Then we also have the part of x y squared. X y squared. Those are like terms again. Those are like terms. So we must consider that separately. the part where we've got x, y squared. X, y squared. Take note. It's supposed to be exactly the same for you to say they are like terms. So we consider that that was going to be positive 3 minus 3. That's a 0 there. 3 minus 3. So it was going to be a 0. So as you can see, this whole part is cancelled. We are just left with what? Y cubed at the end. So we're just going to add y cubed. As you can see, it is what? A positive there. All right. So this is what you're going to have at the end of the day. As we can see, it was just issue of expanding brackets, then you collect the like terms as usual. All right, let's consider another question. So guys, you just need to work as many questions as you can, and you see that it will be just a repetition. 1.32 for 4 marks. It was to simplify this given fraction. All right, so let's see the algebraic fraction that we are given there. That is 3 over x minus 4 plus 2 over x plus 3 minus, so this is 21 over this. All right, so that's 21 over what? X squared minus x minus 12. Okay, so this is what we're given. So if we are to consider this part, we can see that the last term is supposed to be factorized. So we consider there the denominator, then we can factorize. So this is 3 over x minus 4 plus 2 over x plus 2 minus 21 over what? So we're going to factorize. This one is a direct factorization. The coefficient of x squared is 1. So you're going to have 2 brackets. That's x to give us x squared. So focusing on the negative 12 as our constant, what are the products or factors of what? Of negative 12, which will add up to negative 1, the coefficient of x. So what are the products there? The factors of what? Negative 12. There are so many factors, negative 2 and 6, 6 and negative 2, negative 4 and 3, 4 and negative 3. So many. Even negative 12 and 1, 12 and negative 1. But we need of all these factors only one pair that we're going to add and give us what? Negative 1 when we add. So that was best described at this point. If we add negative 4 to positive 3, it is going to give us what? Negative 1. So those are the factors that we are going to need here. Negative 4 and what? Positive 3. So that's negative 4, positive 3. All right, this is positive 3 here, positive 3. So this is supposed to be positive 3 here. All right, so that's a positive 3 there. All right, so let's correct that. Okay, so this is what we have. Given these 3 fractions, we can combine them. All right, we can combine these. What is our LCD of the given fractions? So we can see that we've got x minus 4. It is also appearing here. So we're just going to take that one once, x minus 4. We have got x plus 3. We also have x plus 3 here. So we're just going to take that one once as it is. So if we were to divide the first one, x minus 4 and x minus 4, they were going to cancel and you remain with x plus 3. So it was going to be 3 into x plus 3. If you take the second part, all right, the second part of x plus 3, if you divide this denominator to this one, it was going to cancel, guys. X plus 3 and x plus 3, they were going to cancel. You remain with what? X minus 4. So it was going to be plus 2 into x minus 4. The last part, this one and this, we're going to cancel exactly the 2. They're going to cancel, so you remain with what? With 1 there. So it's negative 21 times 1, since this and this was going to cancel. But as you do that, you imagine, it's just like an imagination. You do not cancel this denominator, you just leave it as it is. All right, so this is what you're going to have, guys. Just expand your brackets, then collect the like terms, starting with the first one, which is to be multiplied by 3. All right, we have got the second one, which is to be multiplied by positive 2, and the last one, which is just to be multiplied by what? Negative 21. All right, so let's expand. 3 times x, that's 3x. 3 is going to multiply positive 3, so that is positive 9. All right, so it's going to have a positive 9 there. All right, then we have got the second part, which is positive 2 times x. That is going to give us 2x. All right, then we have got positive 2 multiplying negative 4. That was going to be negative 8. Negative 21 times 1, that's negative 21. Everything over what? The given brackets as they are. All right, as they are, like that. So let's collect the like terms, guys, as we are going to be working with our like terms. We have got, in this case, all right, here, 3x and 2x. We add these two. So 3 plus 2, that is going to be what? 5 there. So we're going to have 5x. Then the numbers, there is 9, minus 8, minus 21. We can even just use our calculator straightforward. That's 9 minus 8 minus 21, like this. All right, so this is negative what? Negative 20. So we're going to have minus 20 over what? The brackets as they are. There's the LCD or the LCM as it is. All right, so if we are to consider, we are going to see that in the numerator there is something common there. We have got two terms, 5x and the 20, separated with this negative. So between these two terms, do we have any common term? Let's consider the highest common factor between 5 and what? And 20. 5 is the highest common factor. Because in 20, remember, this is 2 into 20, that is 10. 2 into 10, that is 5. 5 into 5, that is 1. So you can see that 5 is the highest common factor between what? Between these two numbers. So we can factor out 5. So 5x divided by 5, that is going to be what? X minus 20 divided by 5, that is going to give us what? Negative 4. Everything over the given denominator as it is. All right. So if we are to consider where we are, we can see that x minus 4 is common between the denominator and the numerator, because this is a product here. Here is also a product. So it is just like we're given 5 times 3 over 3 times 4, like this. When there's a product, you can even cancel. You can even cancel this and remain with what? 5 over 4. So it is the same thing. There is a product here, so you can cancel x minus 4, x minus 4. So at the end, we were going to remain with what? In the numerator, we're going to remain with 5. In the denominator, that was going to be what? X plus 3. All right, so that is what you're going to have at the end of the day. So that is it. Just have to figure out your questions, how they are given. Work with each stage by stage. All right, so that is it, guys. That is it. Just revise as many questions as you can. So that's 1.32. Let's consider another part, which is 1.33. We are given this time again to simplify, but we have got an exponent. Those are exponents there. All right, so let's see. 1.33, we are given 5 to the exponent of 2n plus 2 minus 3 times 5 to the exponent of 2n plus 1. Everything that we are given is 25 to the exponent of n times 4. This is what we're given, all right? So let's try to simplify and see. Remember, I always say when you're given this type of a question where we've got mixed numbers, there is 5, there is 3, there is 5, there is 25, there is 4. try to figure out where the exponent is and write those numbers in simplest form, meaning to say as prime numbers. Those are the numbers which are in what? Simplest form, prime numbers. Can we write as 2, as 3, as 5, as 7? Those prime numbers. So we check 5 is already in simplest form. It's a prime number. There's nothing that we can do. That is the part raised to the exponent of what? 2n plus 2. So that one, it is already in the simplest form. So we're going to have 2n plus 2 as it is, minus 3 times 5 already again. Here the 5 is in simplest form again, as we can see. It's in simplest form. So we cannot simplify that one. We just have to rewrite as it is. So that's 3 times 5 to the exponent of 2n plus 1. Everything that we are given is, we focus on 25. It is not in simplest form. It is not a prime number, this one, 25. 25 is the same as what? 5 into 25, that's 5. 5 into 5, 1. 5 times 5, which is 5 is squared. So meaning to say, in place of that 25, it was supposed to be written as 5 squared to the exponent of what? Of n. Then we use our laws of exponents. Exponent to exponent, you multiply that. So it is going to give us 5 to the exponent of 2n times. The 4 is not necessary for us to simplify. There is no exponent of n there. There is nothing about n. Yes, we can simplify 2 to the exponent of 2, but just leave that one as it is, because there is no exponent of what? Of n. We are focusing with where the exponent of n is. So this one we can just rewrite as it is, like that. All right, now that we have written these numbers as prime numbers, that is in simplest form, we are going to ask ourselves to say, what can be, or what will be the highest common factor if we are to factor out from those terms that we are given the base of 5 there. Because in the numerator, there are 2 terms. We consider this as a single term and this as a single term, separated by a negative or separated by a positive. You must factorize. It is just like you are back to your algebraic expressions, x squared plus x, or it is x squared minus 2x. 2 terms separated by a plus or a minus. Factorization can occur where you just have to factor out the highest common factor. So there are 2 terms. This one is a term. This one is a term separated by this. So you think of what? Factorization. But for you now to factorize, you must properly see the terms there to say, okay, if I factor out what is common, this one, 5 to the exponent of 2n, 5 to the exponent of 2n, 5 to the exponent of what? Of 2n. What am I going to remain with if I factor out? So guys, the stages that you're going to have here, this stage, all right, let me just write it down here, this stage that some can even write to say, this is the same as 5 to the exponent of 2n times 5 to the exponent of 2 minus 3 times 5 to the exponent of 2n times 5 to the exponent of 1. Everything over 5 to the exponent of 2n times 4. This stage is just for you guys to say, okay, you want to properly see these terms separated, to say if I separate this, there's a 5 to the exponent of 2 there, there's a 5 to the exponent of 1. But even if without that, we can even see that, guys, factoring 5 to the exponent of 2n. From this, what are you going to remain with? That is the question. You factored 5 to the exponent of 2n. So you remain with what? 5 to the exponent of 2. Which is the same thing here. If you factor out 5 to the exponent of 2n, what are you going to remain with? 5 to the exponent of what? Of 2. There is no need for us to have that stage. Yes, you can have it. I'm not saying do not indicate this stage. You must if it is necessary. All right? Minus, if I factor out 5 to the exponent of 2n here, what am I going to remain with? I'm going to remain with, there is a 3 there, times 5 to the exponent of what is remaining there. If it is minus 1, use minus 1. If it is plus 3, use that what is remaining there. That is how you simply do this one. So it's 5 to the exponent of what? Of 1. The same thing, if we check here, we factor out 5 to the exponent of 2n. What is going to remain? The 3 and what? The 5 to the exponent of 1, as it is here. So this is just properly, just to for you to properly see it, say, okay, these are the terms that I'm having. But even here, we can even trace them in a proper way. All right. So that is divided to what? In the denominator, there is no factorization, guys. It's a product. You do not factorize something like x cubed times x. There is no factorization. The factorization is between two terms that are being added or subtracted, not a product. So there is nothing here that we can say, even if there was something common to say there is x and x, you cannot factorize for a product. All right. So never think about factorization. So just rewrite as it is there. That is it. All right. So if we are to consider now, the factorization that we have done made us to actually have a product of two terms in the numerator. So why am I saying two terms? We have got the first term outside of the bracket, then the second term being in the bracket. I'm taking the bracket as a single term. So as a product as it is, we are allowed to cancel the numerator and the denominator as long there is something common like this. We can cancel that. Remember, x times maybe y to the exponent of 3 over y times 2x. We can cancel the x and the x. Y into y squared, which is y into y cubed, which is y squared. We can do that because it's under a product. That is the same thing, a product there. So you must simplify now. What is remaining after that? What is it that we have? 5 squared, that is 25, minus 3 times 5, which is 15 over what? Over 4. So as you can see, we no longer have any. We are just left with normal numbers. So that was going to give us 10 over 4, which is the same as 5 over 2, or you can even have it as a decimal at the end of the day. That is what you're going to have there. All right. So as you can see, they're just direct questions. You just need more revision on these typical questions. All right. So let's check another part. What are we given? That's 1.4. Factorize the following expressions fully. All right, we must factorize fully. 1.4, 1, we are given x squared minus 13x plus 42. All right, so there we just gonna consider, guys, this is a trinomial, and the number that is multiplying x squared, which is our coefficient, is 1. So we know that we're just going to have two brackets. That's x here, that's x here. Then we focus on our constant, which is what? 42. What are the products? The factors of two terms, you multiply to get 42. But when you add those two terms, you must obtain what? Negative 13. So as we can see, guys, to obtain a negative 13 by adding, it means you're focusing with a negative to a negative. All right, you're focusing with a negative to a negative. So when you're focusing with factors of 42, focus with what? Negative values. There are so many factors of 42. We have got 14 and 3. So as we are focused with what? Negative, negative. All right. If there is 7 and 6, we're just going to put negative, negative. So many. But which one that when we add, we are going to get a negative 13? These are the ones. If we add negative 6 and negative 7, we are going to obtain what? Negative 13. So those are the two that we're going to need. Negative 7, negative 6. All right. So that was it. We are done on this factorization. Let's consider another one that is on 1.42, where we are given m squared plus m into 4 plus n plus 4n. All right, what are they trying to say here? What are they trying to say? Let's see. If we are to consider, there's nothing common so far. All right, there's nothing common so far. So let's just try to expand this and see, because there is a bracket there. So it can help us if we expand to see if there's anything common, or if you can have four terms at the end of the day. M times 4, that is going to give us 4m. M times n, that is going to give us mn. All right, we are done with this bracket. Then we have got 4n here, which is at the end. All right, so by expanding, it is lucky enough we can figure out to see, okay, this is where we have got 4 terms where factorization by grouping is very, very important to be applied. We think about that one, factorization by grouping. This is what we have here. 4 terms, 1, 2, 3, 4. So let's group into 2 and see if there is anything common between these two. All right, so there is m which is common there, so we can factor out that m squared divided by m, that is going to be m. 4m divided by m, that is going to give us what? A 4. Then for the remaining 2 terms, we can see that n is common, so we can factor out positive n, so that we have got the same bracket as this one that we are given in the first place. So mn divided to n, that is going to give us what? M. 4n divided to n, that is going to give us positive 4 there, as we have got 4n over n. This is going to cancel, and we've got what? A 4. All right, so as we can see, guys, we are at a stage where the 2 brackets are common, and this is exactly what we need whenever we are factorizing by what? By grouping. There is a stage where you are supposed to have 2 brackets which are exactly the same, m plus 4, m plus 4. If you do not have this stage, know that there's something wrong in your factorization by what? By grouping. Anyways, we have got what we need, so we factor out that common bracket of m plus 4. What are we going to remain with here? We remain with the m. What are we going to remain with here? Plus n. It is going to be another bracket that will be part of our answer like that. So this is your factorization. They'll be playing around with you guys. They want to see if you know the basics. They just wanted to trick us with some multiplication, the expansion of bracket first, before you do your factorization by what? By grouping. So you must be able to figure out those in exam. 1.43, another factorization to make our question 1 complete. 1.43, we were given, all right, let's see what we have got there. 2y minus 250 y to the exponent of 4. There are 2 terms separated by a negative, so you're going to think of difference of 2 squares, which actually we are not having for the first time. You can think of difference of 2 cubes, which we are not having. These are not cubes, these are not perfect squares. So what can we do? Let's look for the highest common factor. The golden rule: always factor out the highest common factor. What is our highest common factor? Between the two numbers 2 and 252, that is the one that we can factor out, guys. 2y and y to the exponent of 4, that's y there. So if we factor out 2y, is going to be what? 2y over 2y. Our term there is going to give us 1. Then minus 250, so that's 250y to the exponent of 4 over what? Over 2y, like this. So it was going to be 250 divided by 2, which is negative 125. Already there was a negative there. Then y into y to the exponent of 3. To the exponent of 4, I mean, we are going to remain with the 3 of them. So that's y to the exponent of what? Of 3 that we are having. Okay, anyways, let's see what we have. As we factored out the 2y there, what is remaining inside of the bracket? It is something that is important in our factorization, which is the difference of what? Of 2 cubes. 2 cubes to the exponent of 3. 1 can be written as 1 to the exponent of 3. That's a perfect cube. Minus the 125 that we see, it is same as 5 to the exponent of 3. So it was supposed to be 5 to the exponent of 3, y to the exponent of 3, which we can just rewrite as 5y together to the exponent of 3. So it is the same as 1 minus 5y to the exponent of 3. This part that we are seeing here. So it's a difference of 2 cubes, where we have got our a and our b. Our a as what? As 1. Our b as 5y. So how do we factorize such? It is equal to a minus b into a squared plus ab plus b squared. Remember your difference of 2 cubes concept. So meaning to say we can factorize that, guys. So it was going to give us 2y into what? A minus b. Our a is 1, our b is 5y. So it's a minus b, 1 minus 5y. All right, so that's 1 minus 5y into what? A squared. Our a is 1, guys. So if we say 1 squared, 1 squared is what? It's 1. So that was going to be 1 plus AB. AB, what does it simply means? You multiply your A to your B. 1 times 5y. 1 times 5y is what? It's 5y. So that's plus 5y there. Then plus B squared. The B is what? Is 5y. So 5y squared. That's what? 5 to the exponent of 2, which is 25, y to the exponent of 2, which is y squared, like that. All right, so that is it. We are done. We have expanded. We have, factorized completely this part as we are given in that factorization concept. So they can ask these typical questions. You must be able to attempt due to your basics of understanding of your factorization. All right. Then question number 2, solve for x without using a calculator. All right, 2.11. How can we solve for x on a quadratic equation, guys, without using a calculator? They are simply saying factorize there. Simply factorize. 6x squared minus x minus 1 is equal to 0. So your factorization, guys, here, factorize the way that you understand from your trinomial. Factorize them the way that you understand. So many ways that you can use to factorize. All right, so most of you guys, you said we can apply this the cheat method. Remember, it was 6x squared minus x minus 1. So using that, we can take, remember what we need is to have the coefficient of x squared as what? As 1. So we take the 6 to the constant, you multiply there. So we have removed that 6. So it is now x squared minus x minus 6. As we have got the coefficient of x squared as 1, we can factorize this because we do understand it's just going to be x and x here from x squared. Then we focus with what? The constant negative 6. What are the factors of negative 6? Which will add up to negative 1. Factors of negative 6, there are so many. Negative 6 and 1, 6 and negative 1, negative 3 and 2, 3 and negative 2. So many. But there's only one part. When we add, we are going to get what? Negative 1, which is happening at what? Negative 3 and 2. So there is negative 3, positive 2. Then what is that we are going to do? We bring back the 6 that we had before. Remember, we got this 6 that you multiply, that you removed, so that it is now 1 squared. So you bring back that 6 into our simplification. This is the idea of the question. So we bring it back to the brackets that we are having at the end here. We bring back our 6. So this is the complete concept of this section. So we take this 6 here and also here on x. Where there is x, so you put 6, you put 6 there. This one. Put it here, you also put it here. Where it is common, factor out between these two brackets where it is common. So the first bracket, 3 is common. You're going to factor out 3. What are we going to remain with? That's 6x divided by 3, which is 2x. Minus 3 to 3, that's minus 1. The second bracket, 2 is common. There's 6 and 2, so you factor out 2 there. Factoring out 2, it is going to be 6x divided by 2, which is 3x. 2 divided by 2, which is 1. So the numbers that we factored out are not important, these ones. What is important are the brackets that are remaining. Those are the brackets that we need. That is the answer to this factorization of this part. So we are going to remain with the 2x minus 1 into what? 3x plus 1. So like I said, guys, you can use any way that you understand on your factorization. But at the end, you must have these two brackets. Now that we've got these two brackets, we need to find the value of x. So it follows that for the product of two brackets to be equal to 0, what does it mean? Each must be equal to 0. So it is either 2x minus 1 is equal to 0, or the bracket of 3x plus 1 is equal to 0. So we can solve for x. Minus 1 to the other side is going to be positive. That is 3x is equal to 1 to the other side is going to be negative. So we can divide by 2 to obtain the value of x, which is 1 over 2. Or our x here divide by 3. So our x was going to be minus 1 over 3 at the end of the day. So those are the possible values of x, 1 over 2 or minus 1 over 3. So as you can see, it was just about your factorization there. If you know your basics of your factorization, you are done. You can use any concept. Even if you're to use the quadratic formula, you just need to know that you have to, because you'll be given a perfect square. Wherever wherever you can solve a quadratic equation like that one, where you have got direct values, it means even if you were to use the quadratic formula, you were going to have the square root of what? A perfect square, which is something that you can simplify without a calculator again. All right, 2.12, we were given 3 to the exponent of 2x minus 1 equal to 1 over 243. So that is just to write in simplest form. As you can see, 3 is already in simplest form. Those are your exponential equations. So let's focus with 243. We do understand in the base of 3, that is, or it can be written as 3 to the exponent of what? Of 5. So if you do not know, you can even use your calculator. 243 is equal to what? Then it's a shift fact here, which is what? 3 to the exponent of what? Of 5. So that is what we have. Then we do understand from our exponents, x to the exponent of negative n is the one that gave us 1 over x to the exponent of n. So when we are given something like this, it can be rewritten as what? X to the exponent of a negative. So that is 3 to the exponent of 2x minus 1 is equal to 3 to the exponent of what? Negative 5. Just like this. So this is where we are. And from these guys, we know that these bases, if they are the same, the exponents automatically, they are supposed to be what? They are supposed to be the same. So 2x minus 1 is equal to minus 5. From there, we can solve for x. Taking the minus 1 to the other side, or simply add 1 both sides of our equation. Thus 2x is equal to minus 5 plus 1, which is what? Minus 4. So we can find our x. Divide by what? Divide by 2. So that's it. Our x therefore was going to be negative 2. So those are your exponential equations. Part of your exponents can be having simplification of exponents. They can be solving of those exponential terms, which is now our exponential equation when it is like this. All right. So anyway, you must know the basics of the laws of your exponents. All right. So for x, given an inequality on 2.2, we are given to solve for x. There is x plus 3 everything over 2, which is greater than minus 1, but less than what? But less than 5. All right, so let's get rid of these terms which are surrounding x. There is a denominator there. So let's get rid of that 2. To get rid of this, you must multiply by 2. But it is supposed to be done on each and every term, meaning to say you multiply here by 2, you multiply here by 2, so that we get rid of what? Of the 2. So it follows that you're going to remain with x plus 3, which is greater than what? Minus 1 times 2, which is minus 2. 5 times 2, which is what? Which is 10. So that is what you are going to have. Then to remain with x, there is a 3 which is being added. So we must get rid of that. We subtract the 3, we subtract the 3, we subtract the 3. So this can cancel. So that's x is greater than what? Minus 2 minus 3, that's minus 5. 10 minus 3, that's what? That's 7. So meaning to say here x will be greater than minus 5. All right, but the same x that we are talking about on the other hand is going to be less than what? 10 minus 3, which is 7. So that's a 7 there. All right, so this thing, guys, is just like stuck sometimes. Let's see. That's a 7 there. All right, so that is it. That is it. It was just to solve there. It was just to solve. So meaning to say we have got our x values which are ranging in between what we are given there. Then 2.3, we are given at a restaurant, we are given that a glass of orange juice costs 4 rand more than a glass of what? Of iced tea. It is 4 more than. It is further given that 5 glasses of orange juice and 3 glasses of iced tea together cost what? 84 rand. So these are simultaneous equations that you're going to form there. All right, let x be the cost of what? The orange juice in that case. So the orange juice, we're gonna have a cost as what? As x. Then the glass of iced tea is represented by what? By y there. Okay, 2.31, set up a system of equations, take note, that represent the above information. All right, so let's look into the first equation. They said in that case, in terms of the cost, a glass of orange juice costs 4 rand more than 4 more than. So we are saying the orange juice as we have it, which is what? Which is x. For us to have its cost, we must take the cost of a glass of what? Of iced tea, which is what? Which is y, like this. Then we add 4, because this one, it is 4 more than. So for them to be equal, you must add the 4 to the what? The one that is more than. They are saying 4 more than this, more than that. So that is for them to be equal. Or you say x minus 4, because it is already 4 more. So for it to be equal, all right, it is like this, guys. An equation, these are two things that are equal. So if you have got 4 more than someone, let's say you have got 12, then another person has got 8. All right, you have got 12 rand. This one has got what? 8 rand. For you guys to say you are having the same, because this one is 4 more than. For this person to have this amount of this one, we must subtract 12 minus 4 for it to be equal to 8. Or we take that one which has the lesser value of 8, we add a 4 so that it gives us a 12. Equation, we are saying this is equal to that. This one is already having, they are saying the orange glass is already 4 more. It's already 4. When we see x, it is just like we are looking at 12. It's just like we are looking at 12. That is the condition of our question. So for us to say our x, which is 12, to be equal to that one, we must add 4 to the other one, not to that already which is more than. No, unless we are to subtract from that to say x minus 4. So it is that way. All right. So x, it must be equal to y plus 4 for these two to be equal. That is the only way. Or we can have it like I said, x minus 4 is equal to y. That's another way actually. All right. So that's our first equation. The second one, they said here, all right, it is further given that 5 glasses of orange juice, 5 of them. We are talking about 5 glasses. So if one costs x, one, it costs x. What about if there are 5? It's going to be 5x. You multiply. So the total for those 5 glasses that were being purchased is going to be 5 times the price of each. Each is x. So 5 times x, which is what? 5x. And we must add that one, 3 glasses of what? Of iced tea, each at y. So that's 3 times what? 3 times y there. We must get a total of what? This is the total together. When you combine these 5 and these 3, you must get a total of what? Of 84 rand. So that's an equation on its own. So 2 equations could be formed from that given information. So that is what we're given. Then 2.32, they now said, hence determine the individual cost of orange juice and iced tea respectively. They are just simply saying calculate the value of x, because x is the cost of what? The glass. And the glass of orange juice, and y is the cost of what? The glass of iced tea. So they are simply saying solve for x and what? Solve for x and y. That is what they are simply saying there, because x and y represent the cost. The cost of what? Orange juice. The cost of what? Iced tea. So we can solve. How can we solve this? Already, guys, you see, when you're dealing with simultaneous equations, you choose the method which is best. But in this case, we can see that factorization, if we consider substitution here is the best, because we can see that x is already the subject of the formula in what? In equation 1. So we can take advantage of that equation 1. X is what? Already the subject. So we're simply going to substitute equation 1 into what? Into equation 2. Into equation 2, because already x is the subject of the formula there. So in place of x, we are going to put y plus 4. So that's 5. In place of x, you put what? Y plus 4 there. So that's y plus 4 representing x. All right, plus 3y as it is equal to 84. So as you can see, it's an equation which is only in terms of y. So that enables us to what? To solve for y. Simply expand these brackets, then you collect your like terms, then solve for y. 5 times y there, that's 5y. 5 times 4, that's positive 20, plus 3y, which is equal to 84. Collecting the like terms, 8. 5 plus 3, that's 8y plus 20, which is equal to 84. So 8y is equal to what? We subtract the 20 both sides of our equation. So 84 minus 20 was going to give us 64. All right. Then we can divide by 8 both sides of our equation. So that's y was going to give us what? Y was going to give us 8. So meaning to say, we have got y there representing the cost of what? The cost of iced tea. So the iced tea costs, that is what? That is 8 rand. All right. Then to find x, we can simply use equation 1, because in equation 1, x is already the subject. X is equal to what? Y plus 4. So we can simply use from equation 1. From equation 1, x is equal to what? 4 plus y, or y plus 4. So we can simply substitute 4 plus our y, which is 8. So x is equal to 12. So remember what x represent. So therefore, you're going to have the cost of what? Of it's a glass. They said a glass of what? Of orange juice. All right, orange juice. That was x. Remember, the orange juice is represented by x. So that's 12, which is what? 12 rand. And we have got y there, which is the cost of a glass of what? Of iced tea. All right, considering the iced tea, that is 8. Remember, it is represented by what? By y there. So that is 8 rand. All right. So that was the condition of your question, just like that. Just like that. Just like that. Those simultaneous equations can be given from word problems. All right. You're given a word problem. You formulate. You are the one who is to formulate those equations. Then after that, you solve them. So, guys, do revise. Do revise. It is not only about where you are given the simultaneous equation. You expect those typical questions only. No, they can be like this, where you are the one who is to formulate the equations, then to solve those equations at the end of the day. All right, let's consider question 3. Consider the following linear number pattern. Already they told us it's what? It's a linear, meaning to say there is a constant what? There is a constant difference there. So if there's a constant difference, we just need to figure out what is that constant difference. T1, T2, T3. So that's T2 minus T1. 3 minus 8, that's negative 5. Minus 3, minus 2, minus 3, that's a negative 5. So as you can see, there's a constant difference of what? Of negative 5. So the question on 3.11, it was to determine the next term of the pattern. So from minus 2, we just have to add the constant difference, or constant difference of what? Negative 5. So that was going to be negative what? Negative 7. All right, so just add the difference there. Then determine the nth term of the pattern. So the nth term, guys, from our grade 9 mathematics, where there is a constant difference, we said we can determine our Tn as what? Dn plus c, where d is that constant difference, which we said is what? Negative 5. So that's negative 5n plus c. Then we need to find the value of c. From any of the terms, we can use the first term. T1 is equal to what? T1 is equal to 8. So that's Tn 8 is equal to what? Minus 5 times our n. Our n is what? 1 there. All right, so plus c. We can solve for c. So 8 is equal to negative 5 plus c. Take the negative 5 to the other side. It was going to be 8 plus 5, which is what? Which is 13. So 13 is equal to c. Therefore, our Tn is equal to what? From this stage, that's negative 5n plus 13. Okay, so that was our Tn there. 3.13, determine the value of the 25th term. All right, so this one just substitute, guys, as we are to find T25. N is equal to 25. From this, you substitute. So that is equal to minus 5 into our N, which is what? Which is 25. Just like that. Plus what? Plus 13. So that's our T25, which we can simplify further. Negative 5 times 25 plus 13 at the end was going to give us negative 112. We can just use our calculator direct here. Negative 5, open bracket, times 5 plus 13 like this. All right, so that's negative 112. All right, then 3.14, it was which term of the pattern is equal to this minus 527. So we are given our Tn as minus 527. So which term? They're asking the n value. What is the value of n? So remember, Tn is equal to minus 5n plus 13. So we can form an equation. Minus 5n minus 5n plus 13 must be equal to this tn. They are exactly representing the same thing, tn. So it follows that minus 5n plus 13 and minus what? 517 must be exactly the same. So you have formed an equation where you can solve for what? Where you can solve for n. So that's it. Minus 5n to get rid of 13. Simply subtract that 13 both sides. That was going to give us negative 540. So divide by negative 5 by negative 5. We're going to get negative cancels. So that's 108. All right. So our n is going to give us 108. All right, so that was it on our question. It's supposed to be actually 3 point, well, where am I getting this numbering, guys? It's 3.14. All right, so that is it for 3.14. Just like that, guys, we're gonna have our n as what? 108. Let's consider the other part of the question, which is our 3.2. 3.2, we are given that 3x plus 1, 2x, and these other expression of 3x minus 7 are the first three terms of a linear number pattern. It's a linear number pattern, so we've got T1, T2, and T3. So the question is determine the value of x. Guys, when it is a linear pattern, we do understand there is only one thing that is common there for a linear pattern. It is the constant difference. It is the same T2 minus what? Minus T1, which is the same as T3 minus T2. It is the same. If there was T4 minus T3 like that, you must obtain the same thing. So when this is equal to this, it simply means we've got what? An equation there. It is an equation that we are relating T3 minus T2. When we have got this and this, guys, it's simply we have got an equation there. That's an equation. So we can use the constant difference concept. So let's form an equation. T2, what is our T2? That is 2x. So 2x minus T1. Our T1 is what? 3x plus 1. So it's an expression. Put it in a bracket. 3x plus 1 must be equal to T3. Our T3 is what? 3x minus 7. 3x minus 7 minus what? Minus T2. Our T2 is what? Is 2x. We are subtracting 2x. So the part that you subtract is the one that you can put in a bracket. So that is simplification of what? Of a negative. The part that you are to subtract is the one that is to be put in a bracket. This one, do not worry about putting that one in a bracket, guys. All right. So that is it. You can solve for x. It's an equation that you have formed as the left hand side is equal to the right hand side. So expand the first bracket by what? Negative 1. The number that is outside of the bracket is negative 1. So that's 2x negative 1 times 3x negative 3x. Negative 1 times positive 1, that's negative 1, which is equal to 3x minus 7 minus times 2x. The number that is outside of the bracket is what? Negative 1. So it's negative 1 times 2x, which is negative 2x. Collect the like terms on the left hand side and also on the right hand side. On the left hand side, there is 2x and minus 3x. So combine these two. 2 minus 3, that is 2 minus 3, which is minus 1. So it's minus x minus 1 equal to what? There is on the right hand side 3x and 2x. So it's 3 minus 2, which is what? Which is 1x. So it's x actually minus 7. We need to solve for x. So it is up to you guys. How are you going to take it? We can take this x to the other side. So it's going to be a negative there. So it's minus x, which is minus 2x. We take the negative 1 to the other side of the equation. It was a negative, so it's going to be a positive. So it's negative 7 plus 1, which is negative 6. Divide by what? By negative 2, guys, so that you can have the exact value of x, which was going to give us what? A 3. So that's it. We have got our x value from that. This is how you just simply play around with your questions, guys. You simply play around with these questions. You can say that it's just a repetition throughout. It will be a repetition. All right. Then they gave us a certain condition that if the pattern, which is written as Michael, 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 is continued in that way, we are writing that, guys, right? And so on and so on and so on. What will the 201, which is the 201 first letter be in terms of the order? Like we've got 200, then 201. Which letter are we going to have there when n is equal to what? 201. So this is the exact way, guys. Definitely we're going to count. This is our Michael like this. Then we have got another one. All right. Then we have got another one. All right. So this is the concept here. We've got another one. Then we're going to have another one also. So we're going to count 1, 2, 3, 4, 5, 6, 7. Then you count again 8, 9, 10. So when we are at 201, counting in that manner, which letter are we going to see? So guys, do not waste your time counting up to 201, guys. No. You just say, all right, the word Michael, this one, how many letters do we see in that? There are 7. 1, 2, 3, 4, 5, 6, 7. So if we are to divide 201, which is the term, where are we going to have it? So it's supposed to be 201 over 7. How many times, how many Michaels are we going to obtain from there to say this one is the first Michael, 7. There is another Michael, 7. There is another Michael, 7. How many Michaels are we going to have in this 201? How many are they? All right. So let's take our calculator here. 201 divide by what? Divide by 7. It is going to give us 28, 7 and so on and so on. So it is 28, 7 and so on. So this is what I want you to note now. 201 divided by 7, it gave us 28. So these are 28 full Michaels that we are given according to that name that we are given. There are 27 full Michaels. 28 of them, 28 full. So we have counted to say this one is full, 7. There is another one with 7, 2. There is another one with 7, which is 3. There's another one with 7, which is 4. So we counted 28 full of them. So those 28 full of them, remember, each carries what? 7 letters. So how many letters are we having that we have covered out of 201? Remember, 201 is the total. Out of 201, how many letters are we covered? We take this one, the whole number, 28. So we are going to say 201, our total, minus what? 28 times 7. Remember, we covered 28 full Michaels. Each Michael having what? 7 letters. So we subtract. 5 is the remaining. So it is 28 times. To say 201 divided by 7, it is 28 times. Remainder what? There is a remainder of what? How many letters will remain? Because we are talking about 201 letters. But we covered how many? 28 times 7. So from those 28 times 7, I don't know what we're going to have there. 28 times 7 is what? It is 196. So from 28 full Michaels in terms of the name, there are 196 letters there. So out of those 196, we are saying they are supposed to be 201. So we subtract 201 minus 196, which is the one that gave us what? The 5 that we are seeing. That's a remainder. Because we are saying 5 letters, they do not make up the word Michael, because the word Michael is made up of what? 7 letters. That's why we are saying this one is a remainder. So the remainder 5 is supposed to give us, guys, this is what I'm saying. This is what I'm saying. You're gonna understand me very soon. That is what I'm trying to say. You completed. These are the Michaels that you completed. You completed. We said 28 of them. You completed 28 full Michaels. In those 28, what does it mean? It means that 28 times 7, because each Michael has got 7 letters. It means you covered 196 letters. Those are the letters that you covered in what? In these 28 full Michaels. You have got 198 letters that you have covered. So there is a remainder of what? Of 5 to give us what? To give us 201. That's what I'm trying to say. 196 plus 5 is what? 201. So that remainder are the letters. Remember, guys, this is the word Michael. It is full. It is full. It is full. It is full. Then there are 5 letters that are remaining. From what? From that word Michael. There are 5 letters that are remaining. We did not complete. For us to be at 201, we're not going to have 7, because they said we've got a remainder of 5. So we must count that. 1, 2, 3. We must count, because we need a remainder. Our remainder is supposed to be 5. So this is 3, this is 4, this is 5. The 5th term on our remainder. It means when we're covering Michael, after 28 Michaels, the remaining 5 letters could not finish the word Michael. So the 5th one, this one is the 201. That is where our N is at 201. So what is that letter? The letter is what? Is A. So the 201 term, first term is going to be what? Is going to be A. It is going to be A. Therefore, the letter will be A. So that is the condition. You take the remainder, you divide 201 divided by 7, 28, remainder what? Remainder 5. So the remainder 5, you count it 1, 2, 3, 4, 5. You see that the letter is what? The letter is A. So the letter there was going to be what? Was going to be A. All right. So that is how you play around. This one, it was just like those questions that you just study and see how can I play around with this question, guys. Okay, just study it, go through that. All right, question number 4 we are given. That is f of x is given as -2. All right, this was -2 over x plus 4, which is actually our hyperbola. Then we are asked to determine the equation of the asymptote of f. The horizontal, remember horizontal lines are the lines of y is equal to what? So y is equal to what? This is part of the asymptote. So y is equal to 4. If it was the vertical, it's on the x. X will be equal to what? X will be equal to 0. All right. Anyways, let's move on to another part. Determine the coordinates of the x-intercept. So we do understand for the x-intercept, y must be equal to what? Y must be equal to 0. So in place of f of x, put a 0 there. So 0 is equal to -2 over x plus 4. So let's quickly solve for x. Take the 4 to the other side or subtract 4. That was going to be 0 minus 4, which is -4, is equal to -2 over x. So to find x, we can cross multiply. That will be -4x equal to 1 times -2, which is -2. Divide by -4. That was obtaining the value of x, which is what? 1 over 2. So we are saying our x-intercept is at 1 over 2. So our x-intercept is going to be 1 over 2, 0. Remember, y is equal to 0 for the x-intercept. So that is it. 4.13, sketch this graph of f, clearly showing the intercept of the x-axis and what the asymptotes. All right, so there it was not given where to sketch it, so just gonna try to use the space that we have got here. So that is the part here. So to sketch, guys, that's 4.13. First, we need to know how the shape is going to look like when they are asymptotes, because remember, for the asymptotes, we also have x which is equal to 0 there for this denominator. So x is equal to 0, it's our y-axis, all right? So the y-axis is actually an asymptote. And the other one, the horizontal, remember we said y is equal to what? Y is equal to 4. So let's just say this is where we have got y which is equal to 4. All right, so let's just try to have this one a little bit bigger, going up. All right, so let's say this is where we have got y which is equal to 4 on this line. We're just going to take a little bit up. All right, so let's just say we've got 0, 1, 2, 3, 4, 5, 6, 7, and so on. So y is equal to 4 is somewhere there. So that's going to be our asymptote. All right, so let's just use another one here, just like this. So we have got our asymptote, y is equal to 4, and also the asymptote here, which we said of what? X is equal to 0. X is equal to 0 is also an asymptote, all right? So we also have the intercepts, all right? We're going to consider this is a hyperbola, guys. So in terms of the shape, let's say we've got asymptotes like this, where we have got a negative. All right, f of x is given as negative a over x plus b, whatever that will be given, with a negative coefficient of a there. The shape is going to be this side of the asymptote, another one this side of what? The asymptote. So we must have the intercepts. So those are the ones. Remember, we talked about the x-intercept, which is 1 over 2, 0 there. So that's negative 1, negative 2. If we say this is 1, 2, 3, 1 over 2 in the x-axis, guys, may be somewhere here in between. That's a half there. So that's half 0. That's the only part that we have. We do not have the y-intercept because x is 0. When x is 0, that's what? That's an asymptote. So we just need to know the shape. We just have this x-intercept, which is half. So the shape, according to what we are given here, in between these asymptotes, we're going to have a shape like this for a negative. So the shape is supposed to be like this, passing through half. It cannot cross the asymptote. So just like this, all right? So just like this, here it cannot pass the y-axis because it's an asymptote. Then along these asymptotes again, we do understand we must have another piece of our shape this side. So that's another piece that we're going to have, as it's going to be just trying to approach the asymptote, but it is not going to meet those asymptotes. All right, so that is it. That is the sketch. Y is equal to 4, x is equal to 0. So this is our function of what? F of x. You can even write as it is the equation there. So that was how we were supposed to attempt this question. Then question 4.14, it is now to determine the equation of G if G is formed by shifting the graph of f 7 units down. So as the function is going down, this is affecting the y values. So it means the g of x is supposed to be f of x. A translation or a shift going up or going down, it affects f of x. So when you are going down, it's f of x minus a. All right. So in our case, a, the units that you have moved down, it is how many units? It is 7 units. All right. So if you've got f of x plus a, it's a shift of 7 units going up, minus a, 7 units, a units going down. So that is how you work out a shift. You add to the original function or you subtract to the original function the units that you are given as it is. So it is just like we are given this statement and they are saying find gx. What is our f of x? We take our f of x as it is, the way that it was given there. So that was minus 2 over x plus what? Plus 4. This is our whole f of x. From that f of x, they are saying subtract what? 7, because it was taken down 7 units going down. So you subtract 7 direct on your f of x. Direct. There are no further adjustments. They just simplify 4 minus 7. That is what? That is minus 3. So at the end, this is the new function that is representing the g of x. All right, that is representing the g of x. So let us quickly have question 4.2. Given this sketch, which is being sketched on this part, all right? So as you can see, it's an exponential function, minus 2 being what? Our asymptote, y being equal to minus 2, a, our x, b, our x-intercept, a, our y-intercept, all right? So from that sketch, the question was now on 4.21, determine the coordinates of what? Of A. A is what? The y-intercept. So we can simply calculate this one. That's a 4.21. For the y-intercept, we do understand that x must be equal to 0 there, all right? So when x is equal to 0, y is equal to what? You substitute into this. So 2 to the exponent of 0 minus 2, that's 1 minus 2, which is what? Minus 1. So y is equal to minus 1 at a, which is the y-intercept. So that's 0, negative 1. Remember, x is equal to 0 there. Then 4.22, write down the range of what? Of h. As we can see our h here, it is limited to this asymptote y, which is what? Minus 2. It can go up to any value, but as it is going down, it cannot pass minus 2. So meaning to say we are talking about all values which are bigger than minus 2 for the y values. We are talking about all those values that are greater than minus 2, but y being what? Being any real term as long as it is what? Above minus 2. All right? Then determine the equation of j formed by reflecting the graph of h about the y-axis. If we reflect this graph here about the y-axis, where we see this piece on the other side and this piece on the other side, it was going to be like this actually. So it's going to be like this about the y-axis. So about the y-axis, guys, it's a transformation which you did actually in your grade 9 mathematics, if you still remember. So 4.23, the jx, which is the new function, when it is a reflection about the y-axis, what does it mean? It is a direct implication that is happening on x, a direct effect on x, a direct effect on x, which is f of minus x. If you were given f of x originally, it will change to f of minus x. A reflection about the x-axis, it is minus f of x. This one is the one for the what? About the x-axis. So I think I'm supposed to have a class again of recap of these transformations, list like the easier ways, like if you can see this transformation, you know it represents this one. So a reflection about the y-axis, what is it that is being affected? F of minus x. It is the x values that are being affected. All right. The y values remain the same. The x values will be affected. Meaning to say, if x, let's say at b, we calculated the value, let's say we know that one at b is 2. It will change to minus 2. But the y value remains the same. Y is still at 0. That is the concept. The x values are the ones that will be taken to the other side. Whilst y remains as it is. That's why we are saying f of minus x. It means where we have got our x, put a negative there on that x. That's a reflection that we are talking about. So it was going to be 2 to the exponent of minus x minus 2, like that. All right, which we can rewrite in many ways. Remember, 2 to the exponent of a negative means 1 over 2 to the exponent of x minus 2. So you can even write it that way. It is up to you. So know your transformations, guys, all right, from your basics of your grade 9 mathematics. All right, number 5, we have got a sketch representing f of x, ax squared plus q, and a straight line of g. The point 2, 2, 3 there representing t. Thus, this one is horizontal line, guys, parallel to the what? To the x-axis. It is parallel to the x-axis, meaning to say the y value at that point t, which is 3, it is the same value that we have at this point. So it is actually the equation of the line. Remember, horizontal lines, y is equal to, from the x-axis, y is equal to 0. So this one, what is the y value? 3. So it is the graph of y is equal to 3, or just gx is equal to 3. All right, that is what it means there. Then we have got s, the x-intercept. Then these two graphs, they pass through the point T, P, and R. There's another point P, there's another point R there. At R, we do know, guys, from this type of a graph, we talked about this, guys, when you're given this function of ax squared plus q, it is symmetrical about the y-axis, meaning to say what we see on the right-hand side is exactly the same as what we see on the left-hand side, only that there will be negative. So at P, we know that if S is 4, 0, at P, it will be minus 4, 0. Just a negative. From the origin, this side, it will be what? Negative. The same thing at R there, it is what? Symmetrical to this point at T. So the X value at T is what? 2. It changes to a negative. We are now on the left side. The X values are the ones that are to be what? Affected. So at R there, we must know that it is what? Negative 2, 3. We are just analyzing our graph. All right. Then here we've got our turning point, which is at 0 there, where x is equal to 0. All right. So that is it for now. From the graph that we were given from this sketch, let's consider our questions. The first one, write down the coordinates of what? Of P. The coordinates of P, we have already stated that one, guys, from the symmetrical concept, minus 4, 0 there. So that's minus 4, 0. All right. The coordinates of what? Of R. R also, we talked about this, negative 2 from negative 2, 3, from the symmetrical concept of the graph. I've already stated this. Then write down the equation of G. Guys, write down, you don't calculate, you just write, guys. You just write the answer. The equation of G, we already have it. The y value is 3. So gx is what? Gx is 3. There is no calculation there. Look into the graph, take the answers. Then determine the values of A and Q. There we must calculate. All right. So 5.13, A and Q, where are they found? They are found on f of x. All right. They are found on f of x. So that's 5.13. So to find A and Q is from what? From our f of x. Our f of x is given as ax squared plus q. We do not have the turning point, just like other questions where we take advantage of the turning points. Here, guys, the only way or the best way to answer this question was by substituting any 2 points which lies on the graph of our f of x. We substitute that. All right. We can use these ones, the x-intercept, the point S. But when you use the x-intercept, you use one. You don't use both of them because it's just going to give you one thing. So you take 1 point. You can take point S. All right. Remember, our f of x is equal to ax squared plus q. So from point S, which is 4, 0 like that, we have got the x value, the y value. So we substitute in our equation. Y is what? That's a 0 there, which is equal to a x squared, which is 4 squared plus q. So 0 is equal to 4 squared. That's 16. So it's going to be 16a plus what? Plus q. All right. So that's an equation that we have formed, which is having 2 unknown values. We can just leave it like that as our equation 1. We do the same thing. Like I said, when you take the x-intercept 1, do not repeat with another one. Do not take another one. You use or find another point that you can actually work with. Also, for the point R and for the point T, you choose one. So you can choose point T. So it's best to use original points, guys, which are already on the graph. Remember, T is on what? On f of x. So from point T, which is given as 2, 3, 2, 3, we have got x and y there. So let's substitute that and see what are we going to have. F of x, that's y. So 3 is equal to a times our x. That's 2, so it's going to be 2 squared plus what? Plus q. So 3 is equal to 2 squared, that's 4, times a, so that's 4a plus what? Plus q. All right, so that's another equation that we have formed, which has got a and what? Which has got a and q. So this will be our equation 2. So we can solve these two equations to find our a and q simultaneously. All right, the first equation, 16a plus q is equal to 0. The second one is given as 4a. That will be 4a plus q, which is equal to 3. So it is easier for us to use elimination method, even substitution method. This one, guys, it is in your hands. But we can easily eliminate the q. It is the same here. So eliminate q. Eliminate q. That simply subtract equation 1 minus equation 2. Okay, let's subtract 16 minus 4. That is going to be 14a. Q minus q is going to cancel. So this is 0 minus 3, which is what? Which is minus 3. All right, that is what we were going to have. This is supposed to be 12 here, isn't it? This is supposed to be 16 minus 4. Okay, my mind is tired now. That is 12. All right, so that is 12 there. Then divide by 12 by 12. That's our a was going to be negative 3 over 12, which is negative 1 over what? Over 4. All right, so that is what we're going to have as the value of a. Then to find the value of q, we can simply substitute in any of these two equations. Any of these two equations, as we can make any one of the equations the subject of the formula. We can make any one q from the first equation. We can say q is equal to what? We can take this 16a to the other side, so it's going to be minus 16a. So q is equal to minus 16 times a, which is minus 1 over 4. So that was going to give us a 4 if we simplify there. So these are the values, guys, of a and what? A and q. All right, so that is what we needed, meaning to say our f of x can be written if we substitute that. Our a, we got negative 1 over 4. So it simply means negative 1 over 4x squared plus 4. All right, that is what it means there. That is what it means. We have got these values. So guys, it's all about revision. Just try to work out as many questions. Some you have to solve simultaneous equations. Some they are just direct. There's no need for you to work out these simultaneous equations. It depends with the question. So just try to figure out as more questions in your revisions. All right, considering 5.14, we are given that f of x is equal to k. Determine the values of k for which f has no x-intercepts. All right, so for our x to be not having, for this function not to be having x-intercepts, you focus with what? The y values on our turning point. Remember, f of x is limited to what? To 4. So for all values of k, because our f of x is represented by k, so you work with that f of x, which is the y value at the turning point. So if values are greater than that, because on our graph, this one is limited to 4. So when we say it is now bigger than 4, it means our x-intercept won't be what? It won't have the x-intercepts for those values of k which are greater than what? Which are greater than 4. All right, the typical type of a question that you just need to know the basics. The coordinates of k on f. If f is a reflection on t of t, which is what? 2, 3, about the x-axis. About the x-axis. We talked about this reflection, guys. About the x-axis, it means what? Minus f of x. Minus f of x, guys, it means the y value is the one that is affected. X, y like this, as an original point, is going to change to x minus y. That is what it means. Minus f of x, y is affected. So it is the y there. This is x, this is y. So f is going to be 2 minus 3. That is what it means. The y value is affected. Only the x value remains as it is. Using the graphs, determine the values of what? X, for which f of x minus gx is greater than 0. Guys, I've talked about this type of equation, and they do repeat this type. I said you just take one to the other side. So f of x is greater than gx, all right? So that you can see both of them being positive. Where is f of x bigger than gx? Where is it above gx? Where are we seeing our f of x above gx? F of x is greater than gx. That is what they mean. So this is our f of x, remember. Where are we seeing it on top of this gx, the straight line? On top. This is the section that we can see here. It's clearly there, guys, above here. From R there, above, it's above, up to T. In between from R to T. Remember, at R, we said the value of x there is what? Negative 2. So we are limited from minus 2 up to the value of t, where x is what there? Where x is 2. So meaning to say for this one, we can say x is greater than minus 2. But less than what? But less than 2. So that is the range of values that we are talking about. X must be greater than minus 2, but less than what? But less than 2. F of x is going to be bigger than gx. It's going to be above gx. Then f of x by gx is less than or equal to 0. This is a condition less than negative. So one must be negative. It is either f of x is negative, gx is positive, or f of x is positive and gx is negative. This is the condition that we need. One of the two functions must be negative in that interval. F of x by gx is less than or equal to 0. One must be negative. So let's consider with the points that we have at minus 2. Let's figure out at minus 2. Maybe we can have something there. At minus 2, we can see that this one is in the positive, because we are talking about above the x-axis. We are relating to the what? X-axis. Gx is positive. From minus 2 up to the point P, which is at minus 4. F of x is also positive. So positive times positive is not going to work. But if we consider from P, which is minus 4, minus 5, minus 6 going this side, our f is now below the x-axis. It's now a negative. It's a negative now, below the x-axis. Those are the values that are less than minus 4. But the gx is still in the positive. It is still above the x-axis. So it's positive, whereas our f of x is negative for these values that are less than what? That are less than minus 4. So we can talk about values that are less than or equal to, since there's an equal to here. So you can say also equal to what? Minus 4. One is positive, another one is negative. All right. From minus 2 up to 2, we can see that both functions are above the above the x-axis. They are all positive. This one is positive, this one is positive. So there's nothing that you're going to get. From positive 2 in terms of x, g is positive. F is still positive, is still above the x-axis. All here up to what? Up to the point S. It's positive. So positive times positive, that's a positive. You cannot get that. But once we are at point S, where x is 4 there, the graph of f, we can see now it's in the negative region. It's below the x-axis. Whereas the graph of g, it is still there on top. This one is still on positive. This one is forever positive, just like that. It's above the x-axis. So it's positive. Therefore, values that are greater than 4, 5, 6, 7, and so on. But f of x is now negative. This is what we want. Positive times negative gives us what? A negative. So we can also include this one. We can also include this one, or our x from 4 going up, 4, 5, 6, and so on. X is greater than or equal to 4. For these values that we are talking about, the product of the two graphs is going to be what? A negative, or exactly equal to what? Or exactly equal to 0. So they were just trying to play around with you there, guys. Just try to work out as many questions. Just try to figure out. Then question number 6, we are given that Tembegile wants to buy a laptop computer costing 11,500 on hire purchase. All right. The conditions of the agreement are as follows. Tembekile must pay a deposit. There is a deposit this time. Take note, there's a deposit there. 20% of what? Hire purchase. Then 11% simple interest is charged on the balance. She also pay monthly insurance premium. Take note. Then the balance is settled in 36 monthly installments, which is how many years? 3 years. 36 divided by 12, which is in what? In 3 years. All right. 6.11. Calculate here balance after paying the deposit. After paying the deposit, what is her balance? All right. So let's start with the deposit first. Our deposit is what? 20% off the higher purchase price of. So that's 20 over 100 times the higher purchase price of 11,500. So that was going to give us, all right, 20% of that was going to be 2,300. 2,300, that's 20%. All right. Then the balance is from after paying the deposit. What will be the balance? The money that is on hire purchase, the cost there, 11,500 minus the deposit, minus the deposit which was paid. All right. So that was 11,500 minus the deposit of 2,300 to give us a balance of what? 9,200. All right, so that's it. 9,200 here. 9,200. All right, then another question. Calculate Tembegile's total monthly installments. What is going to be the monthly installment in total? All right, let's start with the higher purchase before we move on to this one, because there's this one for an insurance. All right, we must find the total to be paid over the period of 3 years. Remember, this is the balance that is remaining. She paid something, then there's a balance. So the amount to be paid must be taken from the balance this time. So amount is equal to, this is a simple interest, so P plus 1, 1 plus IN, 1 plus IN there, because it's what? Simple interest that we are talking about. So take note, the principal is no longer the cost price that was on hire purchase. No, because she paid a certain amount of money, 2,300. So the P becomes the balance after paying that amount. What is remaining? 9,200. So that is how you calculate this one. So our P is representing what? The balance this time. If there was no deposit, you use it as it is, because that person never paid anything. All right. But this one paid something, and this is what is remaining. So you work with the remaining amount. All right. Into 1 plus our interest rate. We are told that it is what? The interest rate is 11% per annum simple interest. So 11% divided by 100 is 0.11 as a decimal. So you're going to have 0.11 times the number of years, 36 months, is equal to what? To 3 years. So use your calculator. That was going to give you the total amount to be paid over the period of 3 years. She was supposed to pay 12,236. This is the money to be paid over the period of what? Of 3 years. So how much is she paying monthly from this one? Monthly, she is going to pay how much? The total, which is 12,236, divided by each month. Okay, 36 months. I mean, divided by the number of months total. Remember, there are 36 months. So 36 months, it means monthly she was supposed to pay In that case, it was gonna be to two decimal places 339,89. All right. So this is what we are going to have as a monthly from the hire purchase of what we are given. But this is not the total she is going to pay monthly, because they told us that she must also pay a compulsory monthly insurance premium, 60 rand 75. So that one must be added to have the total for the monthly. So the total monthly installment is gonna be what she's paying monthly on that hire purchase of what she was supposed to buy at once, plus the given amount that is supposed to be paid of what an insurance, which is 60 rand 75. So that was going to give us a total of what 400. That was gonna be 400,64. All right, if we add properly, just make sure, guys, you go through, add properly. If there's anything that is not properly given, let me know so that we can revisit that question. But that is how you answer this question. Where you are given a deposit, you work with the deposit on that hire purchase, because she paid a certain amount of money. All right, 6.2, we are given that it costs 71.72 pounds to fill a car with 55 liters of petrol in what? In England. In South Africa, 1 liter of petrol costs 22.30. So in which country is petrol more expensive if the same car is used? Use the exchange rate between the countries, £1 to what? 23.23. Okay, so this one, guys, we can simply, you can work with 1 liter, you can work with 5 liters, it's up to you. I can simply say, since in England, let's start in England, 5 liters, 55 liters, they cost 71 pounds. All right. That is 71.72 pounds. What about 1 liter? Divide by 5. You can work with those 55 or you can work with 1 liter. So 1 liter costs how much? 71.72 divided by 55. It was gonna be 1 liter approximately to 1.30 pound. It's approximately 1 liter to that. So this is the cost of a liter, 1.30 pound. But remember, we're given that each pound is equal to what in rands, because we have the, in South Africa, we have the cost in what? In rands. We already have that one. All right. So let's talk about this one. For what? For South Africa. In South Africa, what are we having there? So in South Africa, we can see that we have got the cost of a liter. 1 liter costs what? 22.30. All right. 1 liter is equivalent to 22.30. That is the cost in what? In rands. But in England, we are given the cost in what? In pounds. How can we compare to say which one is bigger? While least we are given different currencies, we are supposed to convert one to the other. Is it the rand we're going to convert to the pound, or the pound to the what? To the rand? It's up to you. So as for me, I was going to convert this one, the pound, because we are given here that 1 liter is what? 1/3. But before, we are told that a pound is equivalent to what? It is equivalent to 23.23. What about this one? 1.30 pound. It is equivalent to how many rand? Because that is the cost of what? A liter. A liter. We are comparing to a liter. Simply multiply, because it's going to be more. Cross multiply. So that's x is equal to 1.30 times 23.23 in this case, which was going to give us, that was going to be 30. So it was going to be 30,199 and so on, which is 20,20. So this is the cost that we have in England. Remember, this is in England. So 1 liter is costing 30 rand 20 cents in what? In England. Whereas in South Africa, it's what? 22 30. So which one in that case is more expensive? We can see that it's more expensive in what? In England, as it is more in terms of the rand, as we can see. So it is what? It is expensive in what? In England compared to what? To South Africa, right? So that is how you can play with this type of a question. All right, 6.3, we are given Brent crude oil cost 75. That's 77.36. Guys, I think we had a similar question from the previous question paper that we had. We can see that they do repeat some of these questions. It is $77 per a barrel. Calculate the cost in rands of importing 100 barrels. All right. If the exchange rate is what? This one to a dollar. A dollar is equivalent to 17.83. All right. So let's calculate the cost in dollars, the total. If one barrel that we are given is equivalent to $77.36. What about if they are 100, guys? It's just multiplying by what? 100. So the total cost for 100 barrels was going to be 77.36 times 100, which was going to give us a total of $7,736. Then we can convert this one to rands now, all right, as we have got the conversion that we are given to say $1 is this. So what about 7,736? It is equivalent to what? It's more. So more is a direct proportion where we do cross multiply. So x is equal to the product of these two. So that's 17.3. All right. This thing, guys, it seems like it's gonna stack somehow. That's 17 there. All right, 17.83 times 7736. So you're going to have the total in what? In rands. So that was going to be 137,932.88 to 2 decimal places. So just try to play around these typical questions. You see that they do repeat these questions. All right, then question 7, we are given the letters of the word coordinates were put into a hat. A letter is chosen at random. Determine the probability that 7.11, the letter N is chosen. How many letter N do we have? From the coordinate that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters that we are given. So what about the letter N? How many do we have? It is only one N that we have out of 11. All right. The probability of picking the letter O, how many letter O do we have from there? 1, 2. There are 2 of them out of what? Out of 11. All right. So that is it. That is it for this one. Then 7.2. Balls numbered from 1 to 10 were put into a container. From the balls numbered 1 to 10, list the numbers that will be event A, the factors of 18. All right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the numbers lettered. So A being an event of the factors of 18, it means which terms are we talking about? The factors of 18. When you divide 18 divided by any of these numbers, you're not going to get a remainder. You're going to get exact values. 1 is a factor of 18. 18 divided by 2, that's a 9, so 2 is a factor. 18 divided by 3, that's a 6, so 3 is a factor. 4, there is a remainder. 5, a remainder. 6, there is no remainder. 18, 9, there is no remainder. Those are the events representing A. Then B on 7.22, it is a list of numbers that are odd numbers. Odd. When you divide by 2, there is always a remainder of what? Of 1. those are odd numbers. So 1 is an odd number, 3 is an odd number, 5 is an odd number, 7 is an odd number, 9 is also an odd number. So remember, you just take an even number, you add 1 to get what? To get an odd number. That is the condition, 7.22. Then draw the Venn diagram to illustrate the information above. So as you can see, there are two subsets, all right, A and B. And in these two subsets, is there an intersection? Yes, one is common. One is common. 3 is common. 9 is common as well. So there's an intersection for these two sets. So meaning to say that was going to be represented with an intersection of the two sets. So 7.23. All right, we're just going to have something like this. All right, so as you can see, there is an what? There is an intersection there. So let's quickly have this one. So there is set A, there is set B, our sample space. All right, so let's start with the intersection. The intersection, we have got 1 on the intersection. We have got 3 on the intersection and also the 9 that we indicated there. So those were the numbers on the intersection, 1, 3, and 9. So the question is, what is remaining in A after removing these ones in the intersection? We are remaining with the 2 and what? 2 and 6. What about in B? What is remaining? 5 and 7. So this is what you write in B only. Then covering A and B together, all these A and B, what is remaining out of the sample space? We have got 1, we have got 2, we have got 3, 4. We do not have 4 here, so we must put the 4. 5, we have got it. 6, we have got it. 7, we have got it. 8, we do not have 8, so we must indicate 8. 9, we have got this one. 9, 10, we do not have, so we must indicate the 10 outside of A and B. So that was the set that we are supposed to have, just like that. Then the question further on goes to ask for the probability on question 7.24 of A and B. Remember A and B, guys, that's the intersection. A intersection B. How many terms? 1, 2, 3. There are 3 of them out of what? The whole sample space from 1 up to 10. That's 10 numbers that we are talking about there. All right. B, the probability of A or B. A union B. Combine A to B. Everything that we see. So that is 1, 2, 3, 4, 5, 6, 7. There are 7 numbers that we have out of 10. Then the probability not A, all right, probability of A complement or B, that is union B, combine it to B. It simply means what? What is not in A, the ones that are outside of A like this. These are the ones outside of A. But union B, combine it with B. This is our B. Combine everything with what was outside and what is inside of B. So as we can see, we're going to count everything. They're going to be 8 because these are the only one that we do not need. We do not need A only. So you can easily write this as 1 minus the probability of what? Of A only. Remove what is in A only. Probability of A only is what? 2 out of what? 2 out of 11. Remember, all the terms are 11. Sorry, they are 10, not 11. 2 out of 10. So 1 minus 2 out of 10 is going to be 8 out of 10. That's it. You can have it as a decimal, whatever that you want, or you can, guys, so many ways of answering this question. I just want you to go through it and also try to figure out as an individual if you're going to have the same answer. So that is how these questions, guys, are given as. You can actually totalize these question papers out of 100. You can get 100 out of 100 if you are truly working with mid-zone African motifs, you can actually obtain these marks. All right, so let's do revise as many questions as we can as we are revising for the exams which are ahead of time. Make sure as an individual you understand the basics. Go through the basics. We have got introductions of each and every topic in your syllabus. Go through those videos. They can help you to gather information. Where there is no introduction, guys, you just communicate. There is a community section. Send your message to that community section so that we can visit those sections which need what? More recap or more revision. So that's it, guys. Till we meet again.